Hi everyone, today we're going to continue with describing our angles from section 1.6. Some of this will be in the student journal, not a lot of it, so either you can write on the back of the student journal if you print it out, or you'll need a couple pieces of paper. Okay, so today we're going to talk about vertical angles and, again, linear pairs. So let's start off with this problem here. What is formed when we have two lines intersecting each other? Okay. And hopefully, some of you might already know this, some of you might not, but we have vertical angles. So if I label these angles, notice they're made up of two straight lines, okay? And the vertical angles are what they kind of form the X. So angle 1 and angle 3 are vertical angles, so they're across from each other. Angle 2 and angle 4 are vertical angles. Okay, notice they're made up of supplementary angles, which is what we talked about in the first part of this section. So 1 and 2 are supplementary, 2 and 3 are supplementary, so there's a lot of supplementary angles here. But again, the vertical angles are kind of across from each other. They form like what we call the X there. What's really important to know about all these vertical angles is that they are always congruent. So 1 and 3 are congruent. 2 and 4 would be congruent. Okay, so vertical angles are always congruent. So we have an example here. So fill in the angle measure to the given angle's vertical angle. So if I have this angle here, it's made by intersecting lines. What's vertical from it is again kind of what forms the X. So straight across from it, this vertical angle would be 130 degrees. Okay, so here's some other examples. Find the value of the variable. So again, we have two intersecting lines here in B. So we have SR and PT. And that's made up of supplementary and vertical angles. So again, supplementary form the straight angle. Vertical are kind of diagonal or straight across from each other. So this angle here, SQT and PQR are vertical angles. So again, vertical angles are congruent. So since they're congruent, we know 39 degrees would have to equal that 4x minus 1 because, again, vertical angles are congruent. Now we have an equation we can solve here. So if we add 1 to both sides, divide by 4, you get x to be 10. And again, please read the question after you find x. Don't just assume x is your answer because typically it's not. Find the value of the variable. Oh, in this case, it is our answer. We don't have to find any angle measures, but you always need to go back and read the question. What are you looking for? Okay. All right, I would actually like you to try number C. Pause the video, see what you come up with. Either, again, we've got two intersecting lines here, so are we talking about supplementary angles that add up to 180, or are we talking about vertical angles that are congruent? And set up your equation from there and solve for x. Okay, so hopefully you recognize that these are going to be vertical angles, so they are going to be congruent, again, because they're like diagonally or across from each other. Okay, so you're going to set them equal to each other. Again, vertical angles are always equal. And then solving that equation, finding the variable in this case, so we're finding y equals 34. Okay. All right, now we actually talked a little bit about this in the first day of notes. Okay, let's read through this though. We now know that opposite angles, or like across from or diagonal angles, formed by two intersecting lines are called vertical angles, and they are congruent. We also have a special name for angles that are next to each other. Okay, and this is what we talked about a little bit in the last example, a linear pair. Okay, I want you to pause the video and fill this in. You should know actually from our, again, last example from 1.6, what a linear pair is. So again, see if you can fill that in and push play when you're ready to resume. Linear pair is a set of adjacent supplementary angles. So if I label these again, let me make sure I label them. I want to label them the same as I did up here. Okay. So start with 1 over there. So 1, 2, 3, 4. So 1 and 2 are linear pairs. So again, special, all it means supplementary angles that are next to each other. Another set would be 2 and 3. Another set would be 3 and 4. And our last set would be 1 and 4. Again, so these all add up to 180 degrees, and they're next to each other. Okay. So here we have an example. We're going to circle whether or not they're vertical angles. And then we're going to find the angle measure, given that we know one angle is 35 degrees. So again, we're comparing it to this angle. So circle the vocabulary term that applies to the relation to 35 degrees. So angle 2 in comparison to 35 degrees. This would be what we call the vertical angle, so I'll circle that. Therefore, it's going to be the exact same size. So this would be 35 degrees. Okay. All right. Let's take a look here at F. I want you to pause F and try actually F and G on your own. See what you can come up with for F and for G, circling vertical angles or linear pair, and then the size there for the angle measure they would be. Push play when you are ready to do that. Okay, so angle 1 in comparison to 35, that is next to, so it's adjacent and supplementary. So these two add up to this straight line here. So subtracting from 180, you get that to be 145. On the flip side of it, angle 3 compared to 135 is also adjacent next to it, and they form this straight angle. So again, it would be a linear pair. So subtract from 180, and that would be 145. So again, if you kind of notice here, you've got another set of vertical angles. 1 is congruent to 3. Okay? So those are vertical angles. Another example. Find the measure of angle 1 and the value of x. So again, we have an expression on both sides here. We need to determine, are these a linear pair or are these vertical angles? So if they're next to each other, we got a linear pair. But these are not. These are opposite, or what we call like maybe diagonal from each other. So they're opposite of each other. They are congruent. They are vertical angles. So we can set those next to each other. Okay. So if I solve, subtract a 3x from both sides, add 19 to both sides, so we get 3x equals 51, and then divide by 3. So x is going to be, what's that going to be? 17. So let's read again. Find the measure of angle 1. We found x and the value of x, so we found part of it. Now we just have to find the measure of angle 1. Well, angle 1 is not equal to either one of these expressions, okay? But let's go ahead and plug it in. Let's plug in 17 here. So 3 times 17 plus 32. And again, feel free to plug that into your calculator. Absolutely fine with that. If you plug that into your calculator, you will get that angle right here to be 83 degrees. Okay, so how do we find angle 1? Well, hopefully you see angle 1 and angle 83 are next to each other, so these are a linear pair. They add up to 180 degrees. So if we take 180 minus 83, that will give us the measure of angle 1. So that will give us 97 degrees for angle 1. Again, because these two have to add up to 180 degrees. All right, a few more diagrams here. Find the measure of the indicated angles using the pictures. If you're stuck, consider again any vertical angles or linear pairs, because all intersecting lines like this will form vertical angles and linear pairs. So we have a couple angles here. So we have 33. And actually, to be honest with you, what I like to do is just start filling in my diagram, and then I can go back over here, because I right away see that these two angles are vertical angles, so I know that's 33 degrees. But I also see again more opposite angles here. So I know if this is 59 degrees, 4 has to be 59 degrees. So again, I'm not necessarily going in order here. I'm just seeing, what do I notice on my diagram? Well, I also notice these are vertical angles. They're going to be the same, but I don't know what they are. So how else can I come up with what angle 1 and angle 3 are? Well, remember, we have a lot of straight angles here. So I'm going to point out one angle. Doesn't matter which one it is. I just picked one. I know this whole thing all the way through here is 180 degrees. Well, if this is 59 degrees, this is 33, this is the remaining portion of the angle I need to add up to 180. So if I do 180 minus 59 minus 33, and again I can just simply use my calculator for that, 180 minus 59 minus 33, that gives me 88. So angle 1 is going to be 88 degrees, which is also vertical and congruent to angle 3. So that's also 88 degrees. So again, I'm really using my knowledge of vertical angles and linear pairs, which are really straight angles, to fill in this diagram. No, using that same knowledge, I would actually like you to plug this in as well. The only extra thing we have in here is we do now have a 90-degree angle. But think about your vertical angles here, your straight angles, and linear pairs. Okay, push play, fill this in as best you can, and push play when you're ready to check your answers. Okay. So first of all, I'm going to talk about angle 3. I know that is opposite my right angle, so that has to be 90 degrees. And then I'm going to go to angle 1. Angle 1, again, is opposite of angle 47, so that has to, again, be a vertical angle, so they are congruent. That would be 47. Now I'm going to jump down, so I've done these two. I'm going to jump down to 4. Because if this is 90 degrees, does it make sense that this angle made up of both of those has to be 90 degrees as well? So that makes these complementary angles. So angle 4 would be 90 minus 47. Again, because 47, what am I missing to get to 90? Because again, this is a straight angle, so 90 plus 90 forms a straight angle. So it makes these two angles complementary. So that makes this angle 43, which is also vertical to angle 2. So if you notice, we have a lot of markings. We have a lot of things written down there. That's really what's going to happen in geometry here. You put a lot of information down on your diagram. It's really important with how you label it and mark your diagram. Okay. Now we're going to go to our student journal. Okay. So we have 7 through 9 here. So we want to identify the linear pair. Again, that's the supplementary angles that are next to each other that include angle 1. So if here's angle 1, identify this linear pairs. So angle 1 and, well, here's a straight angle right here, so angle 2. But are there more? And there sure are. Now we can go this direction. So angle 1 and angle 4 are also a linear pair. So again, you can go this direction, and this direction. Identify the vertical angles. There are a lot of them here, okay? So I would like you to actually pause and write as many of them down as you can, and then push play when you're ready to check your answers. Okay, so according to the numbers, here are the 5 that I found. So again, these are angles that are opposite of each other. We got 1 and 3, 2 and 4, 5 and 8, 6 and 9, 7 and 10. There's actually a few more, but we don't have ways of identifying these angles. So according to the numbers, these are the ones that are on here. Okay. And last but not least are angles 6 and 7. So I'm going to highlight those. 6 and 7. Are these angles linear pair? And hopefully you say no. And the reason is they do not add up to the entire straight angle. They only add up to part of it. So because they do not form a straight angle. Okay. All right, and that concludes the notes for section 1-6.